Good day to everyone wherever you are, and the acoustic team thanks the FUS Foundation for the opportunity to talk to you today. We'd like to tell you about Acoustic's 2 kilowatt, fully sampled 2D ultrasound array for high intensity focused ultrasound that has been designated breakthrough device by the FDA. As you're all aware, HIFU can be used to non-invasively destroy tissue inside the body through thermal or mechanical means. While on the surface the mechanism is simple, focus the energy to a controlled spot to either raise the temperature or cause cavitation and disrupt cells. However, in practice, the actual implementation of this is complex. To truly realize the promise of HIFU, the ultrasound transducer needs to meet certain requirements. First of all, there needs to be sufficient power output, either continuous for thermal or instantaneous for mechanical, to ensure that the treatment can be performed quickly and that the depth of penetration is sufficient for the task. This points us to a large area, high power, actively cooled transducer. Controllable and reliable lesion size and shape are also necessary to accurately destroy target tissue with minimal margins. Higher frequencies allow for smaller lesions, but suffer from increased attenuation in the body, reducing penetration and causing heat deposition in intervening layers. A wide area of transmitting surface, both in elevation and azimuth, ensures control over F number and lesion lateral dimensions. Finally, a large number of individually controlled elements leads to the ability to beamform, steering the beam either simply to a point or with appropriate calculations to correct for tissue aberration. These elements must be small enough to allow for high directivity and no grating lobes. A wide bandwidth transducer in the low megahertz frequency range, with many thousands of individually controlled elements spaced down to half a wavelength or less, meets this requirement. Any acoustic beam must be targeted precisely, introducing an imaging requirement. The most common choices are magnetic resonance imaging, which is the gold standard for 3D imaging in HIFU, however requires an MR-compatible transducer and a large, expensive MR system. Ultrasound imaging with additional transducers is simpler and lower cost, however rarely offers 3D volumes to improve targeting. Meeting all these needs simultaneously is the goal of acoustic, and our current system uses custom electronics along with advanced manufacturing techniques to deliver. Using micro beamformers, we have developed MR-compatible acoustic module centered around 1 MHz with over 20 watts per square centimeter acoustic power output and down to half element wavelength spacing. The module shown on the right has 1,000 individually controlled elements with all beamforming and emission plane electronics in the housing. The modular nature allows for multiple configurations. For example, here we see a 4-module version with over 4,000 elements used for research tasks and controlled by a simple USB interface to a laptop. On the right is a larger 16-module version capable of outputting 2 kilowatts acoustic power with over 18,000 elements and active water cooling. To demonstrate the control and adaptability this offers, this video shows an array in a tank of water and is focusing the beam on the surface of the water after bouncing off a metal plate. You can see how rapidly the beam can shift even when steered at high angles. And now, how the large area allows for either multiple foci to be targeted rapidly in succession or simultaneously at lower power. This system has been tested within an MR, and you can see the temperature monitoring of the target within the MR, as it forms a recognizable S-shaped made up from multiple lesions. In clinical use, our current system is placed in the bed of an existing MR, assembled in a few minutes. The patient lies on top of the applicator and treatment begins. On the right, you can see thermal lesioning as predicted by modeling, along with actual lesioning in a porcine model. In summary, Acoustic have a fully sampled high-power modular 2D ultrasound array deployable for multiple configurations. It is compatible with MR imaging, and the architecture allows development of simultaneous ultrasound imaging in our next generation devices. Thank you.